Okay, so the number above the division bar is the numerator. The number below the division bar is called the denominator of the fraction. Okay. All right, now you can have two types of fractions. You can have what are called proper fractions. Proper fractions are fractions where the numerator is strictly less than the denominator. Okay, so any fraction where the numerator is less than the denominator is called a proper fraction. Some examples of proper fractions would be like 1/2, 2/3, 11/13, 96/120. All of these are examples of proper fractions. Okay, proper fractions where the numerator is strictly less than the denominator. If, on the other hand, the numerator is not less than the denominator, then we would have what's called an improper fraction. And that occurs when the numerator is greater than or equal to the denominator. So some examples of improper fractions would be like 7/3. 9/9 is classified as being an improper fraction because the numerator is equal to the denominator. Okay. 101/97, that's an improper fraction. So those are examples of improper fractions. All right, any questions so far here? All right, let's go to our textbook on page 64. I want to point something out here. So we'll dial up our book, go to page 64. Okay. Ladies and gentlemen, if we look at this number line here in figure 3 on page 64 in your textbook, notice that this number line starts at 0 and then kind of ends at 1. And notice that interval from 0 to 1 has been partitioned up into 3 equal size what intervals? Do you agree? All right. So the first interval would go from 0 to 1/3. The second interval goes from 1/3 to 2/3, and the third interval goes from 2/3 to 1. Now, what's another name for 1? Well, another name for 1 is 3/3. Do you agree with that? 3/3. In fact, ladies and gentlemen, there's an infinite number of ways of representing the number of 1. You could represent the number 1 as 2/2, 3/3, 4/4, 5/5, 100/100, 1,000/1,000. Do you agree? Okay, that's what 1 is. Let's go down here. Notice the top number line is partitioned up into equal size thirds, ladies and gentlemen. Then what we've done is we partition each of these thirds up in half, and we go from the number line being partitioned up into thirds down into the number line being partitioned up into smaller units called sixes, okay? So in 1/3, as it turns out, there are what? 2 6 in 1/3. All right, in 2/3, there are 1, 2, 3, 4 6 in 2/3. All right, another name for 1 is 6/6. Do you agree? What if we take each of these 6s and divide them into halves? Well, then we go from 6 6s to 12ths. So in 1 6, there's 2 12ths. In 2 6, there's 4 12ths, or in 1/3, there's what? 4 12ths. Do you agree? See how this is working here? How many times could we subdivide each of these intervals into smaller intervals? Is there any limit? Do you agree I could break these 1/12ths up in half and then we'd go to what? 24ths? Do you agree? 1/24ths, 2/24ths, et cetera, et cetera. Then I could subdivide the 1/24ths up into what? Half again, and I would have 48ths, 1/48ths, 2/48ths. So ladies and gentlemen, theoretically speaking, you could keep subdividing these intervals into smaller intervals as much as you could possibly fathom. Does that make sense? Okay. All right. Notice in each case, there's names for one here. One name for one for the top number line is 3/3, and then 6, 6, and 12, 12. So all those are equivalent names for one. All right. So as it turns out, ladies and gentlemen, it kind of looks like, if you look at these number lines here, it kind of looks like 1/3 is an equivalent fraction to what? 2/6. Do you agree? Which is equivalent also to 4/12. Isn't that true? Kind of looks like 8/12 is equivalent to 4/6, which is equivalent to 2/3. All right. And so we're going to look at this concept of equivalent fractions here. Okay. In fact, if I give you a fraction, ladies and gentlemen, how many equivalent fractions do you think exist for any fraction? What would be your guess?
I don't know.
Well, suppose that we're just given a fraction a over b here. Well, as I claim that you can crank out an equivalent fraction to a fraction a over b if you just take the numerator and the denominator and multiply them by the same number. Everybody see that there? If you multiply the numerator by the number c and the denominator by the same number c, you will have what's called an equivalent fraction to the original fraction a over b. In a similar fashion, if you are given a fraction, whether it be improper or improper, and if you divide the numerator by the same number, c in general here, you will also have an equivalent fraction. These will be equivalent fractions. That's why I have the equal sign in between them. Okay. So let's use our diagram here. What fraction of this diagram is shaded? That would be 1/2, correct? What if I subdivide this diagram, subdivide each of these pieces of this diagram up into halves? Now what fraction of the diagram is shaded?
2/4.
2/4. So 2/4 should be equivalent to what? 1/2. Do you agree? And I could go further here. I could keep going to the end of time here. I could divide each of these partitions up in half further. Okay. Now what fraction is shaded now? Looks like 4 out of what? 4/8. You see? But we could continue to do this forever. Do you agree? Continually subdividing these pieces up in half, and we could keep cranking out what are called equivalent fractions. See how that's working there? All right. But there's got to be an easier way to crank out equivalent fractions instead of doing these diagrams, because these pictures can become very tedious. All right. But there is an easier way. For instance, if I take the fraction 1/2 here, to generate the equivalent fraction of 2/4, all I would have to do is take 1/2 and multiply the numerator and denominator by what? By 2. And do you agree I would generate the equivalent fraction of 2/4? Everybody see that there? Okay. To generate the equivalent fraction of 4/8, I would take the fraction 1/2 and I would multiply the top and bottom by 4. And I would generate the equivalent fraction of 4/8. See how we're doing this here? Okay. In fact, ladies and gentlemen, you could take 1/2 and multiply the numerator and denominator by any same number. Give me some other number that I haven't used other than 2 or 4, any number. Just pick a number.
8.
8. I multiply the numerator and denominator by 8. I'll crank out the equivalent fraction, which is 8 what? 8/16? 16 is equivalent to 1/2, which is equivalent to 4/8, which is equivalent to 2/4. These are all equivalent fractions, right? All of these are equivalent fractions. So I have a question for you. If I give you a fraction, how many equivalent fractions does any fraction have? What would be your guess? How many?
Unlimited?
What's that?
Did you say it was unlimited?
Yeah, unlimited, infinite number, we would say. Any fraction has an infinite number of equivalent fractions. That's true. Doesn't matter if the fractions, It doesn't matter if it's proper or improper. You can always crank out an infinite number of equivalent fractions for any fraction, just by multiplying the top and the bottom by the same number. You'll keep cranking out equivalent fractions. So that's really amazing when you think about it. Likewise, ladies and gentlemen, you can go backwards. Instead of multiplying the numerator and denominator by some number, you could what? Divide the numerator and denominator by the same number and generate an equivalent fraction. So like 40 over 80, I could divide the numerator and denominator by the number 2 and crank out what equivalent fraction? 20 over 40? Do you agree? 20 over 40 is equivalent to 40 over 80. Then we could go onwards. You could take this 20 over 40 and further what? Divide the numerator and denominator down by 2 again and crank out yet another equivalent fraction of 10/20ths. Isn't that true? You can do this again. You can take 10/20ths and divide the numerator and denominator down by 2 again and take it down to what? 5/10?
Yes.
5/10 is equivalent to 10/20ths, which is equivalent to 20 over 40, which is equivalent to 40 over 80. These are all equivalent fractions. Or you could take 5/10 and, believe it or not, you divide the numerator and denominator by 5, and you can take it down to yet another equivalent fraction, which is 1 what? 1/2? Ladies and gentlemen, 1/2 is equivalent to 5/10, which is equivalent to 10/20ths, which is equal to 20 over 40, which is equal to 40 over 80. You see how we can do that? So given any fraction, ladies and gentlemen, we can always crank out equivalent fractions, whether we multiply or divide the numerator and denominator by the same number, correct? Isn't that true? You can always do that. Okay. So, like if I give you the fraction 7/12, can anybody give me an equivalent fraction? I'll tell you what, give me an equivalent fraction where the denominator has to be 24. What would be an equivalent fraction of 7/12 where its denominator has to be 24? What would the numerator have to be?
14.
14, that's right, because the 12 in the denominator got multiplied by 2, so you'd multiply the numerator by 2 also. Then you'd crank out an equivalent fraction of 14/24, which is equivalent to 7/12. See how this is working here? So any fraction has an infinite number of equivalent fractions. Infinite number. All right. Now, when it comes to negative fractions, ladies and gentlemen, this is very interesting. If you have a negative fraction where you got the negative sign that precedes a fraction, you know, technically it doesn't matter where you put the negative sign. You could attach the negative sign to the numerator, or you could attach the negative sign to the denominator. All of these are equivalent to each other. Everybody see that there? These fractions are all equivalent. So in other words, if I have like -2/3, do you agree I could say this is equivalent to -2 over 3? Or I could say that's equivalent to 2 over -3. Aren't these all equivalent? They're all equal to each other. They all have the same place on the number line. Okay. All right. What if I have a negative numerator over a negative denominator? Well, do you agree if I have like a fraction that says -a over -b, I could rewrite this as -1 times a in the numerator over -1 times b in the denominator? You buy that from here to here? Okay. Now, do you agree I can split this up and put -1 over -1 times a over b? But later on, what's anything divided by itself? What is this reduced to? Or what is this equivalent to?
1.
+1. And 1
Positive.
times a over b is just what? A over b, correct? So to make a long story short, when you have a negative numerator and a negative denominator, that's equivalent to saying that that fraction is really equal to the positive numerator over the positive denominator. Isn't that true? It's always going to be true. So like if I give you -5 over -8, what is this really equivalent to? What's -5 over -8 really equal to? Based on what we just did here. It's really
Positive
equal.
at 5/8.
That's right.
5 over 8.
5 over 8, exactly. There you go. Same thing. All right. Any questions about any of this here? Okay, working with fractions. Now, one's an interesting character. If I take like some number A and divide it by 1, what am I always going to get? What's anything divided by 1 is all? What is anything divided by 1? Always equal to what?
One.
Itself.
Yeah.
So
Sorry. Okay.
Itself.
And what if I take anything and divide it by itself? What's that always equal to?
1.
1. And that's true, like I said, if you have a negative something divided by itself, it will still be what? 1. Okay. All right. Let's have a little bit of fun here. I'm going to give ourselves some fractions to play around with here. 5/8, 5/6, 3/4, and 2/3. And Liz, what I want to do here is I want to write these fractions with a denominator of 24. So I want all these fractions to take on a common denominator of 24. And then once we do that, we'll be able to compare these fractions as to which one's larger, which one's smaller, et cetera, et cetera. We'll be able to sort these fractions from smallest to largest, let's say, or largest to smallest, whatever we want. Okay. Now, what we're going to have to do is we're going to have to take each of these fractions and build them up into equivalent fractions where all the denominators have to become what? What did I say?
24.
All become 24. So that's our goal. We want to build all these fractions up into equivalent fractions where we want all the denominators to become 24. You see, you cannot compare fractions for size unless you get a common denominator. It's impossible. It's like trying to compare apples and oranges. It just doesn't happen. Once you get a common denominator, though, then you can compare the fractions by comparing their numerators. So the first goal here is to build all these fractions up into equivalent fractions that all have the same denominator. And I am requiring that all my denominators become 24 there. Now, 5/8 would be equal to what equivalent fraction with the denominator 24? What did I multiply 8 by to build it up to 24?
3.
3. So you got to multiply the numerator also by 3 to crank out an equivalent fraction. So 5 times 3 is 15. So 15 over 24 is equivalent to 5/8. Those are called equivalent fractions. Similarly, what did I multiply 6 by to build it up to 24?
4.
4, so you're going to multiply the numerator by 4. And 5 times 4 is what? 20. So we say 20 over 24 is equivalent to 5/6. Those are equivalent fractions. 4 times what builds the denominator of this third fraction up to 24?
6.
4 times 6, so you got to multiply the numerator by 6 also. 3 times 6 is 8. And so therefore 18 over 24 is equivalent to 3/4. These are equivalent fractions. Finally, what's an equivalent fraction of 2/3 with a denominator of 24? Well, you'd have to multiply the top
16.
fraction by 8, correct? So 16, 16 24s, as it turns out, is equal to 2/3. Now that we have a common denominator, we can easily compare the numerators for size, for relative size. So if I want to label these from smallest to largest, left to right on my paper, what numerator is the smallest of all these numerators?
The first one.
The 15 24s. Do you agree? So 15 24s is less than, what's the next larger numerator after 15?
Would be
16 24s, right? And now what's the next larger numerator after 16?
18.
18. And finally, what is the largest numerator of the bunch?
20.
20. And so therefore, ladies and gentlemen, as we can conclude, therefore, we would say that 5/8 is less than what? 2/3, which is less than 3/4, which is less than 5/6. Do you agree? There you go. So if you had all these measuring cups in your kitchen, let's say, what would be the largest measuring cup of all of these? It would be 5/6. 5/6 would be the largest. What would be the smallest of all these?
8/5.
5/8 would be the smallest. See how this is working here? Okay, so to order fractions from smallest to largest or largest to smallest, you first have to get a common denominator. And once you get a common denominator, then you can compare, you level the playing field, so to speak, and then you can compare the numerators. But if you don't have a common denominator, good luck. It's going to be very difficult to determine what fraction is larger than the other one. You must get a common denominator, okay? And then you're in business. All righty. Any questions about how we ordered or sorted those fractions from smallest to largest there? Okay. Remember, this is being recorded, so like if you miss anything, you can always go back, ladies and gentlemen, and you know, watch the recording at your leisure. All right, maybe we could try another one. Let's try to order these fractions. Order the fractions. And again, we'll choose to go from smallest to largest on our paper. -1/4, -3/8, -5/6, and -5/8. Can you think of a number that all of these denominators divide into evenly? 4, 8, 6, and 8. Can you think of a number that?
16.
What's that?
16.
16. Well, 8 will divide.
Oh no, sorry, 24.
4, but yeah, 6 does not divide into 16. So
That's 24 again.
Yeah, 24. So you know what? Our least common denominator that we're going to shoot for is called 24. LCD stands for least common denominator. Okay, so we're going to build all these fractions up into equivalent fractions that all take on the what? The denominator of 24. So all these fractions are going to take on this common denominator of 24. And by building these up to equivalent fractions with a common denominator, we'll be able to compare their numerators and order these fractions. Okay. All right, so what would be an equivalent fraction of -1/4 that has a denominator of 24? Can you tell me what that fraction would have to be?
So it'd be 6/24.
Yeah, -6/24. -6/24 is equivalent to -1/4. What would be an equivalent fraction of -3/8?
9/24.
Negative
-9.
-9/24. That's correct. How about -5/6? What's an equivalent fraction of this?
-20/24.
20/24. Equivalent fraction of -5/8.
-15.
-15/24. Okay. Now, remember what I said when we have negative fractions? It doesn't matter where we put the negative sign. Let's attach the negative sign to all the numerators. So we got -6/24. We have -9/24. -20/24. And we got -15/24. Now, to order these fractions, we just compare our numerators. So which numerator is the smallest of the bunch? Which numerator is the smallest?
-6.
Careful, the smallest. Remember, the further you go to the left on the number line, the smaller your numbers get.
Oh, I see.
Careful. -20 is what? Furthest to the left on the number line of all the numerators, isn't it?
Mm-hmm.
So -20/24 is the smallest fraction of the bunch. What's the next larger numerator? We accounted for that one.
-15.
Yeah, -15/24 is the next larger fraction. Good. What's the next larger numerator after -15?
-9.
9. And what is the largest numerator of the bunch here?
-6.
6. Therefore, if you want to bring back your equivalent original fractions, you would say, therefore, that -5/6 is less than -5/8, which is smaller than -3/8, which is less than the largest fraction is -1/4. And there you go. See how we ordered those from smallest to largest, left to right. Okay, so again, the key is you got to get a common denominator. If you don't get a common denominator, it's going to be very difficult to order fractions. It's not going to be easy to do. All right. Okay, let's see if we can do this problem here. We all have that accounted for there?
Mm-hmm.
All right, suppose I give ourselves a number line to play around with here, and notice my number line goes from -1 up to what? +1, doesn't it? That's the interval that I'm interested in, -1 to 1. And how many tick marks do you count between -1 up to 1? Let's count them here. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so, ladies and gentlemen, my scale is broken down to the smallest unit, which is what? What's the smallest unit that this is broken down to, the scale here? Is it broken down to 1/2 or 1/4 or 1/8 or 1/16 or 1/32 or 1/64? What would you say? How many tick marks did I count?
8.
Oh, well, there were more than 8. There were 1,
2,
2,
3.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, what, 16? So this scale is broken down into 16ths. Do you agree?
Oh, okay.
16ths. Let's try to locate these numbers here. Where would -3/4 be located on this number line? -3/4. Remember, this is -1. So, ladies and gentlemen, as far as -3/4 is concerned, we would want to consider this scale broken down into fourths. Do you agree? So like this is -1/4, there's -2/4, and there's what? -3/4 and -4/4. Do you agree -1 is another name for -4/4? So where would -3/4 be? As far as fourths are concerned, this would be -1/4. This would be -2/4, better known as -1/2. And this is -3/4. Do you agree -3/4 would be right here? -3/4. Correct? Amazing that there. That's where -3/4 would be if you break your scale down into fourths. But ladies and gentlemen, suppose I want to locate -7/8 now. Now we have to break our scale down into 8s, not fourths, but 8s. So let me wipe these out here. Now we need to think of our scale broken down into 8s, not fourths. So let's try to locate -7/8 here. This, ladies and gentlemen, would be, let's see here. Oh, you know what? I said this was broken down in the 16ths. That's not correct. Broken down in 8s. This would be -1/8. This is negative what? 2/8. -2/8. This is -3/8. This is -4/8. -4/8 is another name for -1/2. So this would be -4/8. This would be -5/8, -6/8, and negative what? What's this? This is negative what? 7/8. Everybody see that there? -7/8. That's where the -7/8 would be. What's another name for -1? -8 over what? 8? -8/8? True? -8/8. Where would -3/8 be? Well, we start at 0 and we count down by 8s. There's -1/8, -2/8, and here's -3/8. That would be the location of -3/8. Okay. Where would -1/4 be, ladies and gentlemen? Now you need to think of your scale broken down into fourths, not 8s. Here's 0. This was what? -1/4. -2/4, -3/4, -4/4. So here's 0, here's -1/4. -1/4 is another name for what? -2/8. Do we agree? -1/4 is equal to -2/8. That would be -1/4, which is equivalent to -2/8. Notice that. Where would 1/2 be? Well, if you want to locate 1/2, now you need to think of breaking your scale down into halves. Here's 0, here's 1. So halfway between 0 and 1 is right here. So this is 1/2. So there's the location of 1/2. Where would 1/4 be? 1/4, we would break our scale down into fourths. So this is 0. This is 1/4. 1/2 is another name for 2/4. This, ladies and gentlemen, would be 3/4. This is 3/4, and this is 4/4. Another name for 1 is 4/4. So 1/4 would be located what? Right here. This is 1/4. Seven eighths. Where would 7/8 be? Now we break our scale up into eighths. So this would be 0. This is 1/8. 2/8, but another name for 2/8 is 1/4. Do you agree? 3/8, 4/8, but what's another name for 4/8?
1/2
1/2 or 2/4. Do you agree?
or 2/4.
So there's 4/8, there's 5/8, 6/8, but 6/8, ladies and gentlemen, is another name for 3/4. 7/8, here's 7/8. So there would be 7/8 here, right there. And another name for 1 is what? 8/8. Do you agree? This would be 8/8. Do you see how this is working here? How we're partitioning the scale up into whatever units we need to locate these fractions here? Where would be 4/4?
1.
What's that?
At the
1.
+1.
That's right.
Yeah.
4/4 is right there. Same thing as 1, correct? Now, how about 16ths? Ooh, it gets more murky now. Ladies and gentlemen, in order to break the scale up into 16ths, we would have to take each of these units, which is 1/8, and what, halve them. Do you agree? Break them in half. So this would be 1/16. 2/16, excuse me, -1/16. -2/16 is another name for -1/8. -3/16 right here. -4/16 is another name for what? 2/8. -5/16. -6/16 is another name for -3/8. -7/16. -8/16 is another name for -4/8 or -1/2. -9/16, -10/16, -11/16, -12/16, -13/16, -14/16. Wait a minute. I lost it somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then -15/16 would be here, and then -16/16 would be here, which is another name for what? -1, -16/16. So where would it be -15/16? It would be right in here, -15/16. -1/16 would be what? Right here. This would be right here, -1/16. So it got a little messy here, ladies and gentlemen, but you can see how if you keep like having the intervals, all right, you keep going to smaller fractions, okay? So, you know, this might hopefully help you to be able to read a ruler a little bit better. For instance, if you look at this ruler here, this is inches, this is my inch scale here, okay? So what would this denomination be right here? If this is 0 inches, this is 1 inch. What is this right here, this line here? How many inches is this line right here, do you think? 1/2 of an inch in between 0 and 1. It's 1/2 of an inch right in here, okay? You see all these little lines on my ruler here? What is my scale broken down into? Let's count all the little tick marks between 0 and 1 here. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each of these little lines represents what fraction, ladies and gentlemen, of an inch? 16th? Because I counted 16 tick marks. Do you agree between 0 and 1? So this would be 1/16 of an inch. There's 2/16 of an inch, 3/16, 4/16, 4/16, by the way, is 1/4, 5/16, 6/16, 7/16, 8/16 is another name for 1/2. Do you agree? 9/16, 10/16, 11/16, 12/16 is another name for 3/4, 3/4, 13/16, 14/16, 15/16, and 16/16, another name for 1. Everybody see how that worked there? That scale? Okay, so being able to read a ruler is a survival skill for the real world. All right. Okay. Any questions about that there, ladies and gentlemen? Okay, let me see something here. But now, if I wanted you to locate between 0 and 1 here, 2/3, you would have to put how many tick marks in between 0 and 1 to locate 2/3? What would you have to do in here? How many tick marks?
Okay, so 2.
Okay, you'd want to divide this interval up into what, thirds? Do you agree? Equal
Yes.
thirds. So this would be 1/3. Well, see, I should be using a ruler here. Call that 1/3, and this is 2/3. Do you agree? Equal thirds, 1/3, 2/3, and what, 3/3? Another name for 1 is 3/3. So 2/3 would be right here. Do you agree? That'd be 2/3. You see that how we did that there? Divided it up into thirds, right? There's 1/3. Out here, there's 2/3, and then there's what? There's 3/3. All right, if I gave you between 0 and 1, and I wanted you to locate, let's say, 2/4, where would 2/4 be? How would you divide this interval 0 to 1 up in order to locate 2/4?
Put 3 check marks or tick marks.
Yeah, you could divide it up into fourths. Do you agree? Equal fourths. So 1/4, 2/4, 3/4, and then what, 4/4? Another name for 1 is 4/4. So 2/4 would be, this is 1/4, this is what, 2/4, this is 3/4, and there's 4/4. So 2/4 would be right here. Do you agree? What's another name for 2/4, by the way? What's an equivalent
1/2.
fraction? Yeah, 1/2. So that's also known as 1/2. And you can see this is clearly halfway in between 0 and 1. You see how this is working here? Okay. So you can always take an interval and subdivide it up into any number of tick marks that is necessary to locate a fraction's position. If you wanted to go from 0 to 1, and in this case, ladies and gentlemen, you wanted to locate, let's say you want to locate 6/8. How would you locate 6/8 between 0 and 1? Well, now you'd have to subdivide your interval up into what? 8s. Do you agree? Into 8s. So this is the halfway point here. So this is 1/2, better known as what fraction over 8? What numerator over 8? 1/2 is equal to what over 8?
4/8.
4/8. So this would be the 4/8 tick, the fourth of the 8 tick marks. Do you agree? And if you divide this up here in half, half of a half is 1/4. But what is 1/4 equal to as far as a fraction over 8 is concerned? That would be 2/8. 2/8. Okay. So this is 1/8, 2/8, 3/8, 4/8. And we could subdivide this up here. So 1/8, this would be 1/8, 2/8, 3/8, 4/8. Halfway here, 5/8, 6/8, 7/8. And what's another name for 1? 8/8. Isn't that true? 8/8. So where would 6/8 be? 6/8 would be right here, correct? What's another name for 6/8 though? It's really equal to what? What does this reduce down to? If you reduce it down by 2, down to what?
3/4.
3/4.
3/4.
So this is also 3/4. Okay, known as 3/4 there. Okay. So does that make sense? If you want to locate a fraction, you just subdivide the interval up into whatever you need to accomplish that. All right. Okay. And if you wanted to locate like 5/16, I mean, you'd have to start further subdivide in half each of these 8th intervals. Do you agree? You have to subdivide this one, this one, this one, this one. This interval has to be halved. 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 Now I got this broken down into 16ths, do I not? There's 1/16, 2/16, 3/16, 4, 5/16, 6/16, 7/16, 8/16. Another name for 8/16 is 4/8 or 1/2. 9/16, 10/16, 11/16, 12/16. You agree? 12/16 is equivalent to what? 6/8? Isn't that true? 12/16, 13/16, 14/16, 15/16, and 16/16. Another name for 1 or 8/8 is 16/16. So that makes sense how you can, take an interval and keep subdividing it, okay, in the smaller and smaller units. And you could go on forever. You could subdivide it into 64s, 128s, 256s, 512s. You could go on forever. All right, let's try to reduce a couple of fractions. Like if I give you a fraction like of 80/90, can anybody give me a number that divides into both the numerator and denominator? Any number that divides into 80 and 90.
10.
10. So we could reduce this fraction down by 10 by dividing the numerator and denominator by 10 and take it down to what? 8/9?
Mm-hmm.
That's good. All right, that's good. Now, ladies and gentlemen, I said we're going to be integrating our calculator into the scheme of things in this class. So I'm going to go grab the calculator and show us how we can reduce 80/90 a little bit quicker on the machine. Okay. So I'm going to bring up the calculator. I'll just bring up the TI-30. It works the same way on the TI-34. You just type in. Now, right here, ladies and gentlemen, this key right here, in fact, let me go to the key history here. You see that key here, N/D? That's your fraction key. When you hit this key here, N/D, that enables you to type in a fraction. You see that? Now that I hit that key, I can type in 80. Hit my down arrow key on my arrow keypad, hit the down arrow key, and then I'll go down into the denominator, and then I type in what? 90. 80/90. Now, how does 80/90 reduce? Well, to reduce it is pretty simple on the calculator. Just hit enter, and it's reduced for you. You see that there? 8/9. Isn't that cool? All right. So we could maybe reduce a couple of these manually without, using the calculator without having to go through the drudgery of doing these manually. So you can do this one on your calculator, 273/385. Let's see if we can reduce this fraction, ladies and gentlemen. Of course, you can do it manually, which would take some time. Do you agree? What does this reduce down to? Let's see. I don't think 13. 3 is not going to go in there. 273/385. Hit your fraction key again and type in 73/385. Hit enter, and you get 39/55. 39/55. Now, how do you think they may have reduced that down manually? Does anybody know how they might have taken that down to 39/55? Well, it's not obvious. Do you agree? How they got it down to 39/55. But can you think of any number that divides in the numerator and the denominator here? That's far from obvious too. Do you agree? And your calculator could maybe help you out there. Let's see. Can we find any number that divides into 273 and 385 on our calculator?
Mm, At least 7.
What's that?
7.
Seven work? Okay, so if we divide the numerator and denominator down by 7, let's see, will that take it down a little bit here? 273 divided by 7 reduces it down to 39. And 385 divided by 7 reduces that down to what? 55.
Yeah.
And we would say that these numbers are relatively prime to each other in the sense that they only have a common divisor of 1, meaning that this is said to be in what form? That's said to be reduced. Do you agree? Or we say it's in simplest form, that fraction. Simplest form or reduced. That cannot be reduced down anymore because the only number that divides into 39 and 55 is 1. And anytime that occurs for a fraction, we say it's reduced if it only has a common divisor of 1 for the numerator and denominator. All right. Okay, so reducing fractions, ladies and gentlemen, really was the order of business of section 2.2. So in a nutshell, we have kind of covered section 2.2 there. Isn't that something? Can you reduce a fraction? All right. And I'll let you reduce it using your calculator. Or if you want a challenge, you can reduce it down, you know, a little bit more in a manual way if you desire to do so. Does that make sense there? Okay, so I'll let you either use your calculator to take it down immediately, or if you want a little bit of a challenge, you can reduce it down, you know, step by step. All right, either way, I'm happy with that. Okay. All right, let's move away from fractions just for a moment here, and let's go into the world of decimals. Decimals. So we're going to go back to our textbook here, and I'm going to go to page, or try to go to page 159 in the textbook. Page 159. And ladies and gentlemen, we're going to try to start beginning working with decimals a little bit here. On page 159, they give you this wonderful diagram here, halfway down through the page here. And it locates the decimal point right here. You see where it has the arrow pointing? Yeah, that's where the decimal point is to be understood, to be located. Now, if we go one place to the left of the decimal point, we go to the ones place. 2 places to the left of the decimal point is the tens place. 3 places to the left is the hundreds place. 4 places to the left is the what? Thousands place. What do you think the next place would be beyond 1,000?
10,000.
10,000, and then
100,000.
100,000, and then after 100,000, 1 million.
1 million.
And then 10 million, 100 million, 1 billion, 10 billion, 100 billion, 1 trillion, 10 trillion, 100 trillions. Agree? Okay. Now to the right, one place to the right of this point is the place that's called not the tens place. Notice it's called the tenths place. Tenths, the tenths place. 2 places to the right of the decimal point is called the hundredths place. 3 places to the right of the decimal point is called the 1,000ths place. And then 4 places to the right of the decimal point is the 10,000ths place. 5 places to the right of the decimal point is the 100,000ths place. What do you think would be the next smaller denomination after the 100,000ths place? What would be your guess? After the 100,000ths place.
1 million.
Yeah, the 1 millionths place, and then the what? The 10 millionths, and then the 100 millionths, correct? And then the 1 billionths, the 10 billions, the 100 billions, the 1 trillions, the 10 trillions, the 100 trillions. Does that make sense there? All right. So I have a question for you. What is bigger, a tenth or 10? A tenth or 10? What's larger? A tenth or 10?
10.
10. 10's huge. 10 is 10 times larger than 1. But ladies and gentlemen, 1/10 or a tenth is only 1/10 the size of one whole. You agree? In other words, how many tenths would you need to make up one whole? How many tenths, 1/10 would you need to make up one whole?
10.
10 of them. Yeah, one whole is 10 times larger than 1/10. Or we say 10 is 10 times larger than one whole. All right. All right. 1/100th is only 1/100th the size of one whole. So to make one whole, you would need 100 1/100ths. Do you agree? You need 100 1/100ths to make one whole. Notice 100 is large. It's 100 times bigger than one whole. All right. 1,000th is 1,000th the size of one whole. You need 1,000 1,000ths just to make one whole. So one whole is 1,000 times bigger than 1,000. One whole is 10,000 times bigger than 1/10,000ths. Okay. Any questions about those decimal place names there? Okay. Let's see if we can name some decimals now. You got a snapshot of those names there? See if we can just take a snapshot in our minds of these names here, ladies, and try to remember these places, okay? Notice it's kind of weird in a way because one place to the left decimal point is called the ones place, but one place to the right is not called the once place. We don't have anything like that. It's called the tenths place. Starts off at the tenths place, not at the once place. Kind of weird how that works, but just notice that. All right, let's try to name some decimals now. So if I give you 0.03, ladies and gentlemen, how do you name this decimal? How would you write its name in words? The 3 is in what place?
3/10.
Now this was the what? This was the tenths place.
Oh,
Forgot
300.
already. Hold on.
Well, it just, okay, because the one.
One place to the right of decimal point is the tenths place, but 2 places to the right of decimal point is the what? The hundredths place. So we would read this as 3 what?
Hundredths.
300ths. Not 300s. No, hundredths. DTHS ending. Must have that THS ending. 300ths. Okay, not 300s. No, 300. Oh, 300 would be way over here. Do you agree? This is 300. There's a huge difference between 300 versus 300ths. 300 is colossal in size compared to 300ths. All right. All right, try this one here. How would you read this decimal? 52.7. We should read it properly as 52 and what? What would you read this as? 52 and?
7/10.
You are correct. 52 and 7/10. Notice the THS ending, 7/10. The word, excuse me, the word and suggests the decimal point. So when you see the decimal point, you put the word and in there. So you got 52 and 7/10. The 7 is in the tenths place. Everybody see how we're reading these here? Okay, so 52 and 7/10. Okay. All right, so how would you read this decimal here? How would you read that? Or how would you write its name in words? You would say 2 and what? Or what?
Hundredths.
Hundredths. That's correct. Not 100, but hundredths. THS ending. Good. All right, here's a challenging one. How about 0.0015? How would we read this decimal? How would we read this decimal here? We would say, give you a hint, 15 what? The 5 is in what place? Well, let's try to remember the names here. This is the what? Tenths?
Tenths. hundreds, thousands,
This is the
10,000.
hundredths. Okay. This is the what? Thousandths. And this is the
10,000.
That's right. That's the 10,000ths place. 10,000ths. So we would read this as 15 10,000ths. THS ending required. I didn't say 15,000. I said 15 10,000ths. 15 10,000ths. All right. Okay. All right. Now, let's try to do a couple of these problems. Just try to write the following numbers as a fraction or a mixed number. Okay. Let's try this one. 362.78. But you know what? The way we write this as a fraction or as a mixed number is depending upon how we read it. So how should we properly read this number? We would say 362 and what? And 78 what? What place is the 8 in? This is the tenths place. The 7's in the tenths. And this is the
Hundreds.
hundredths. So you know how we would write this as a mixed number? We would write it the way we read it. We read this as 362 and 78 over, what did you say? 78
Hundreds.
hundredths. Everybody see how we wrote that? We wrote it the way we read it. It's 362 and 78 hundredths. This is called a mixed number because a mixed number has a whole part to it and it has a fractional part to it. Everybody understand how we wrote this decimal as an equivalent mixed number? So you write it the way you read it. All right, so let's try this one here, 9.009. How would I write this as an equivalent mixed number? Well, how do you read it? Because how we read it is how we're going to write it. So how do we read this, ladies? I'm going to say 9 and what? 9 and 9 what? What place is this 9 in over here? This is the tenths, hundredths, and what place is this? Thousandths. So we would read this as 9 and 9 what?
Thousands.
Thousandths. And there you go. So we read this as 9 and 9 thousandths. That's how we write it as a mixed number then. 9 and 9 thousandths. One, two, 305. How would we write this as a fraction? Well, the way you write it as a fraction means depends on how you read it. So how should we properly read this decimal? We would say 305 what? What place is the 5 in? This is the what place? The tenths? Hundredths? What's this? Tenths? Hundredths?
Thousands.
Thousands?
Yes.
10,000s?
So 100,000.
100,000s. So we would read this as 305 hundred what? Thousands? So 305 literally over 100,000. There you go, ladies and gentlemen. That's how we write it. We write it the way we read it. 305 hundred thousandths. Is this making sense how we're writing a decimal as a fraction or a mixed number? So you write it the way you read it, okay? The way it's read is the way it's written. So how would I write this as a mixed number? How do you read this number here? How do you read it?
It would be 20
25. Sorry.
hundredths. No,
25
not
and what? 25 and,
hundredths.
wait, 25 and hundredths.
Or would it be
25
25,
and
12 hundredths.
12 hundredths, right?
1200s now?
25 and 12 hundredths. There you go. 25 and 12 hundredths. That's right, because that's how you read it. 25 and 12 hundredths. Is this making sense how we're writing decimals as fractions?
Mhm.
Do you think like on a future quiz, you might be able to do that?
Yes.
Okay. All right. What place is the 5 in? So I'm going to give ourselves some numbers here. You identify the place, the name of the place that the 5 is in. All right, what place is the 5 in this number? What's the name of this place?
Tens. No.
Hundred.
Hundreds.
Okay, so wait a minute. One place to the left of the decimal point is the what place?
Oh, I see.
Tens.
Oh, tens?
I see what you're doing.
Oh, wait a minute.
Pushed it around.
One place to the left of the decimal point is called the what? The ones.
Oh, the ones.
Uh-oh.
Wait, you had to look. I'm sorry, I should have been looking at that.
2 places to the left is what? The tens place, and then the hundreds. Okay. That's why you might want to just try to just memorize these names here.
Yeah, because it's like a number line, but backwards, but not really with the decimal. It's all confusing.
Okay, so let's go back now. So the 5's in what place? This is the what? Ones. This is the
Oh,
Tens.
tens place.
okay.
So the 5 is in the tens place. Let's try this next number now. What place is the 5 in now? What place is the 5 in now?
Oh, okay.
Thousand.
Tens? Hundreds? What
Thousand.
place? Yep, thousands. The 5 is now in the thousandths place, not thousands, but thousands. Make sure you have the THS ending, okay? All right. Let's try another one here. What place is the 5 in now? What place is the 5 in now in this number? What place is this?
So be
This is the what place? Tens? And what
tenths.
place is this?
Hundreds.
Hundredths. Yep, the 5 is in the hundredths place. THS ending. Make sure you have that. Okay. Here's one. A little bit tricky. This is so simple. It'll fly under the radar. What place is the 5 in now? What's the name of this place here?
So that would be the ones.
Ones place.
Ones.
This is the ones place. Or you know what? Another way of saying digits in the ones place is to say it's the what? It's in the whole number place. Whole number place. So 5 is in the whole number place. Okay. All right. So how about 29.52? What place is the 5 in now?
So be the tenths.
Tenths. That's in the tenths place. Okay. All right, one last one here. What place is the 5 in now? What place is the 5 in now? Out here.
Thousands.
Thousand.
Ones, tens, hundreds, thousands, correct? This is the 1000s place, or we just say thousands place. If you want to say 1000s, that's okay too. That's the 1000, not thousands, but just thousands.
Thousands.
1000s. The thousandths place would be what? The 3 out here. Do you agree? That's the thousandths place. THS ending. Thousandths. This is the 1000s place. Are we seeing a difference here? All these locations?
Yes.
Okay. Let's see. So we are navigating right now through section 4.1. So it's kind of like these sections are kind of seamless with one another. I'm going to go to page in my textbook now. I'm going to go to page 163. And on page 163, My notes indicate that I wanted to go over 27 through, well, 36, but I don't know if we'll have time to do all these. Let's just try to do a couple of these here. Can you write these words as a decimal? Can we go backwards? Like 55 hundredths. How would you write it as a decimal? 55 hundredths. How would you write that as a decimal? 55 hundredths. Well, let me give you a little hint. 55 hundredths. That's what number 27 says, 55 hundredths. That means the 5 of the 55, ladies and gentlemen, has to be in the what place if this is to be 55 hundredths. This better be in the what place?
Hundredths place.
The hundredths place. It better be in the hundredths place. 55 hundredths. So the decimal point has to go where? Where do I put my decimal point then for this to be the hundredths place? Does the decimal point go in between the fives? Do I put my decimal point in here? Oh, that'd be the tenths
No.
place, correct? No,
Mhm.
where's the
Before
decimal?
the fives.
Yeah, it has to go right here because this is the tenths and this is now the hundredths, the proper place. And you can put a 0 in front of the decimal point if you want to. Sometimes it's omitted, but in nursing circles, if some of you are going into nursing, they require that you precede a decimal point with a 0 if there's no other non-zero digits. Okay, that's to stay off any possible mistakes in administering medication erroneously. Okay, just might want to put the preceding 0 there. All right. I taught the dosage class one time at Washington Community College, and I remember that you want to put the 0 here as a flag because it's throwing up a flag warning you that there's a what decimal point here. Do you agree? Because look at, if you don't put the 0 there, if you had a long night, you're really tired, you come in on the job, you read the medication dosage, you might read this as like 55 milligrams. Ladies and gentlemen, that's not 55 milligrams. That's 55 hundredths of 1 milligram. Do you agree?
Right.
You might kill a patient. Do you agree? All right. That 0 there is a flag, a warning telling you there's a decimal point here. So this is 55 hundredths of a milligram, not 55 milligrams. All right. So careful on that one. Might want to put the 0 in front of the decimal point if there's no non-zero digits to the left of the decimal point. All right, let's try number 28, 235 10,000ths. Would you be able to write those words as a decimal? 235 10,000ths. Tell you what, on your paper, put down 235. Just write 235 down on your paper. But what's it saying? It's saying 235 10,000ths. So the 5 of the 235 has got to be in the what place? 235 what? 10,000ths? Do you agree? So that 5 better be in the 10,000ths place. Being the case, where would I have to put my decimal? Would I put my decimal between the 3 and the 5? No, not even close. That would be 23 and 5/10. The 5 has to be in the 10,000ths place.
Wouldn't it be between the 2 and the 3?
Between the 2 and the 3. If I put my decimal point here, this will be 2 and 35 hundredths. No, the 5 has to be in the 10,000.
Okay.
Where do I put my decimal point? If I put it here, then this will be 235 what? Thousandths. Do you agree?
Yeah.
Oh, where do I put my decimal point?
It'll be before the 2?
Before the 2? Well, I have to put something even before the 2. What do you think it is?
0.
Yeah, you got to put a 0 here, then put the decimal point right here. Now this is correct because this is the tenths place, hundredths, thousands, 10,000ths place. So 235 10,000ths would be this decimal. So you really kind of got to know the names of your places, don't you, in a way,
Yes.
to have a shot at this. And I think that's a no-brainer. All right. You try, this one's easy. Try number 29, 6 and 9/10. How would I write that as a decimal? 6 and 9/10. 6 and 9/10.
6.9.
6.9. That's it. 6.9. 6 and 9/10. 6.9. That was an easy one. Now this next one is not so easy. Number 30. 45,000 45,000 and, remember, and represented the what? What was the name? Well, what did and represent? The what point? The decimal point?
Yes.
Okay, so 45,000 and 621,000. See if you can write that as a decimal. 45,000 and 621 thousandths. How would you write that as a decimal? 45,000 and 621 thousandths. Well, up to the word
No,
and.
49 point.
Yeah, before we
Yeah.
come up to the word and, we got to have 45,000. Do you agree?
Mm-hmm.
You got to have 45,000, before the decimal. So you at least have to have 45 what thousand. Do you agree? You got to have this at least because it says 45,000. And is the decimal point. Remember, the word and means decimal point. And what now? And what? What did it say? 45,000 and here we go. 621 thousandths. So write down the number 621, but the one of the 621 better be in the what place?
Thousand.
Yeah, it better be in the thousands place. So 621 thousandths. Let's see, tens, hundreds, thousands. Okay, so 621 thousandths. Agree? Because that's the thousands place. And we got our answer. 45,000 and 621 thousandths. That would be your answer. Some of these are a little tricky, aren't they? But you see how these are working? Okay, it's a lot more difficult to go from words to a decimal as opposed to a decimal to words, isn't it?
Mm-hmm.
A lot more tricky. But obviously, the starting point is you have to know the names of your places. Okay, because if you don't know the names of your places, like I said, it's going to be an uphill battle, to say the least. Right? All right. Let's move on to that section. We're now moving into section 3.5. It is entitled Order of Operations in Mathematics. Section 3.5. I gave you this problem here. Suppose I gave you 7 times 5 minus 3. And I wanted you to evaluate this numeric expression. I have a question for you. What do we do first? Do we multiply first or do we subtract? Or does it matter?
Or
What
I
would you?
I would multiply first.
Okay, you'd multiply first. So you must have where did you get that idea from? You must have seen something in the past, huh?
Yes, I have.
Oh yeah, all right. So, yeah, ladies and gentlemen, you see, on planet Earth, we have to abide by what's called the order of operations, so that we all get the same answer for this problem, regardless of the country we're in. Okay, you know what? Mathematicians have sat down and universalized how we should move through this numeric expression. And the first thing we should do here is multiply before we subtract. 7 times 5 is 35, and then 35 minus 3 is 32. This numeric expression has only one answer on planet Earth. It's called 32. Doesn't matter what country we're from, okay? All computers and calculators have been programmed to abide by the order of operations. What is this order of operations, which, kind of guides us along as to how we are to simplify numeric or variable expressions? Well, the order of operations, step number 1, ladies and gentlemen, we're always searching for things inside parentheses. Anything inside parentheses receives the number 1 attention. Secondly, then we look for what are called exponents. Exponents receive the next level of attention. Like if you have 2 to the 3rd power, you need to evaluate that next as 2 times 2 times 2, which is 8. So we look for exponents next. Then we look for multiplications and divisions in the expression as they occur from left to right. Left to right, okay? Multiplications, divisions from left to right. So in some cases, as we move from left to right in our expression, we might encounter multiplication before division. But then in some other expressions later on, we might encounter division before multiplication. It just depends which operator occurs first from left to right. That is the one that we do. Okay. Last but not least, then we address adding or subtracting as they occur from what? Left to right. So in some cases, we might run into addition before subtraction, but in other cases, in some other expressions, we might run into subtraction before addition. That is called the order of operations. And students have memorized the order of operations by attaching an acronym to it. Please excuse my dear Aunt Sally. Please, P for parentheses, excuse, E for exponents, my, M for multiplications, dear, D for divisions, Aunt, A for additions, Sally, S for subtractions. You see that? Please excuse my dear Aunt Sally. As a way of remembering the order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplications, divisions as they occur from the left to right, additions, subtractions as they occur from left to right. The order of operations. And so these order of operations are going to instruct us as to what we should do first, second, third, etc. Do you agree? To arrive at a simplified result for a numeric expression. It's called the order of operation convention. And everybody on this planet abides by this order of operations. And all calculators and computers that are on this planet have been programmed to obey the order of operations. Okay. Now, I don't know what they do on Mars, but I know on Earth, we obey the order of operations. I'm not sure what the Martians do on Mars. Maybe they got some other convention. But on planet Earth, we do things in that order mathematically. So help me to simplify this expression. Ladies and gentlemen, how would I simplify this expression here? What would I have to do first? I see multiplication, I see subtraction, I see parentheses, I see addition, I see an exponent. What would be the first thing you have to do?
Start with the parentheses
Yeah,
first.
we're inside the parentheses first, but inside the parentheses, we have addition, we have exponents. What takes precedence, addition or exponents? Please excuse E for what? Exponents?
Exponents, yes.
We'd have to do the exponents first. So here's what we'd have to do first. We would have to square 9. And 3 squared is 3 times 3, which is what? 9. Now we're still inside the parentheses. So the next thing we'd have to do is add. 2 plus 9 is what? 11. And we could drop the parentheses around the 2 and the 9 at this point in time. We got it down to this now. What's next, ladies? I would multiply or subtract.
Multiply.
Use my dear Aunt Sally. Multiplication is above what? Subtraction. Do you agree?
Yes.
We got to multiply next. 5 times 6 is what? 30. And what's 30 minus 11 now? That should give us our answer. 30 minus 11 is, I believe, 19. And we would get our answer right there. Everybody see how we did that there? Okay. Don't you want to know how we could do this a little easier on the calculator? Because we can. I'm going to do this problem over again, but I'm going to show you on your calculator how we can type this in all on one line on our calculator and hit the enter button and get 19. Isn't that going to be amazing?
Yes.
You're going to save a lot of time, isn't it? Okay, let's bring up our calculator and I'll show you how to type this in. So here we go. I'm going to go get the calculator. All right, here it is. I'm going to clear my screen. Now I'm going to type this in on my calculator here. So I start off by saying 5 times 6. 5 times 6. These are my keys. Whoops, hold on a second here. I got to clear my keystrokes here. I'm gonna do this over again here. So 5 times 6. That's what I type in first. 5 times 6. Now I got to go get in my subtraction button. Notice on this calculator, there's a difference between your subtraction button and your negative button. Notice your minus or subtraction button is to the right of the number 9 key. Your negative button is to the left of the enter button. Do we see the difference with those keys there? So you got to be careful. This is 5 times 6 subtract. Hit your minus button. subtract open parenthesis. Your open parenthesis is above the number 8 key. Open parenthesis. Type in 2 plus 3 squared. Now, how do we square something on our calculator, ladies? There's two ways to square a number on your calculator. You could just hit your X squared button, which is off just to the left of the number 7 key is your X squared button. Or above your X squared key, you could first of all just hit your power button. This little hat symbol on this button is called your general power button. It enables you to raise a number to a power. You could say 3 raised to the what? Second power. Now, you know, my cursor has been elevated to the exponent level. How do I bring it back to the main level? All you have to do, ladies and gentlemen, is hit your right arrow key to bring this cursor, which is part of up here on the exponent up here, just bring it back down to the main level. So watch this when I hit my right arrow key. Watch what happens to the cursor. See it come back down to level? Everybody see that there? Closed parenthesis now. Ladies and gentlemen, I typed that expression in all in on one line on my calculator. Everybody see that there? I literally typed in this whole expression on one line of my calculator. Now, when we hit the enter button, we better see what answer. What
19.
had we better see? 19?
Well, not nine.
Wait, what was the answer to that? It was 19?
It was 19.
Yeah, we better see 19, correct? Well, let's hit enter. Here we go. 19. Isn't that amazing? Your calculator obeys the order of operations. Your calculator behind the scenes very quickly actually did things in the same order that we did things. Does that make sense, ladies and gentlemen? Pretty neat, isn't it? That can save us a ton of time by using the calculator. All right. Okay. So it looks like we can maybe use our calculator to help us out here a little bit. So ladies and gentlemen, that is awesome. That's actually not only going to be much more convenient, it's actually going to turn our problems into downright enjoyable problems, isn't it? Because we're going to, you know, be able to enjoy using our calculator. So what a fabulous course this is that we can use our calculator here. Let's try to simplify this expression using our calculator. We want to take 7, subtract 1 3/5, and multiply that 1 3/5 by 2 1/2. What do you think we would do first if we did this problem the long manual way? Would we have to multiply? It's understood there's multiplication in between these parentheses, understood. Would we have to multiply or subtract? What would we do first? Order of operations.
Multiply.
Yeah, so your calculator is going to multiply these mixed numbers together first, then it will subtract that result from 7 to get the answer. Let's go to our calculator and see how we would type this all in on our calculator on one line. Okay, so ladies and gentlemen, I'm going to bring up the calculator and we're going to do this problem on our machine. First of all, wait a minute, did you write that problem down on your paper? Did we all write that problem down?
Yes.
Okay, write that down. Now here we go. We're going to go to the calculator. All right, so I'm going to clear my screen. Now here we go. We say 7. Oh, I have a question for you. Is this a minus sign or a negative sign? What button do we hit? Yeah, that's a minus. That's a subtraction sign. Okay, so make sure you hit your subtraction button, not your negative button. So we say 7 subtract. You can go with an open parenthesis, and now we need to type in the mixed number 1 3/5. How do we do that on our calculator? Well, ladies and gentlemen, above the fraction button, N over D, let's look at our keyboard. Above your N over D button, do you see where it says U and N over D?
Yeah. Oh, I see.
What am I saying? You got your fraction button here, correct? N over D. Above your fraction button, you see U and N over D. Ladies and gentlemen, this is your mixed number function on your calculator. But to access it, since it's above your key, your fraction key, you have to precede your fraction key with the second button first. So we're going to have to hit our second button first, then our fraction key. That'll bring up the mixed number template. Okay, so let's go back and try that out. So I hit my second button and then my fraction button, and there's my mixed number template. Now we just type in 1 3/5. 1, hit your right arrow key to go to the numerator. 3, Hit your down arrow key to go down into the denominator, 5. How do I bring my cursor back up to level? What do I hit? What do you think? How am I going to bring my cursor back up to level, ladies and gentlemen? Because right now it's in the denominator. Hit my right what? Arrow key? Right arrow key, and notice my cursor is right back up to level. Closed parenthesis. Now you can say times, but you don't even have to say times. You could just start off with another open parenthesis. Your calculator understands its multiplication in between the parentheses. Now we're going to type in the mixed number 2 1/2. How do I type in 2 1/2? How did I do that again? I hit my second key followed by my what? Fraction button. That brings up my mixed number template. Now we type in 2 1/2. 2 1/2. Hit right arrow key to bring your cursor back up to level and close it off with a closed parenthesis. Ladies and gentlemen, we typed in our expression on one line. We should be able to get our answer now by hitting our enter button. Hit enter and boom, there's your answer. So what is your answer? Just 3? And we're done. Your answer is 3. Isn't that amazing? You got to love this calculator. Isn't that amazing? The answer is 3. Okay. All right. Let's try this one here. Let's try to simplify this one. Open parenthesis. We got 3/5 plus 1/10 closed parenthesis. And now they have a big old open bracket here. And they say 1/2 subtract the fraction -3/4. They want us to simplify this expression. Now, you know, there really is no difference between parentheses and brackets. So, ladies and gentlemen, when we type this in on our calculator, we're not going to use a bracket here. We're just going to use another open parenthesis. It serves the same purpose. Brackets and parentheses serve the same exact purpose. Okay. There's no difference between brackets, parentheses, and braces. So parentheses equal the same thing as if you were to use brackets, equal the same thing if you were to use braces in mathematics. Same thing. They serve the same purpose. Okay. All right, let's go ahead and try to type this in on our calculator and see if we can dial this up. I'll make sure that you can do this on your machine, and we'll see what we get. So let's go. First of all, did we write this down on our paper? Okay. If we wrote that down, let's see if we can go negotiate this on the calculator now. So we'll start off, clear your screen first. Start off with an open parenthesis. Type in 3/5. So you have to hit your fraction button to dial up 3/5 plus 1/10. Fraction bar again, 1/10. Right arrow key to bring your cursor back up to level, closed parenthesis. You can say times, as it's understood as multiplication in between the parentheses, and then another open parenthesis, which was really your open bracket. I'm just using a parenthesis again. And then we type in 1/2. Subtract, open parenthesis, -3/4. So now we hit our negative button at the bottom of our keyboard, -3/4. Negative, and then the fraction button, and then 3/4. Right arrow key, closed parenthesis, and then another closed parenthesis. There we go. We typed in that whole expression in on one line on our calculator. Now, obviously, the expression is a little bit too big to fit all in on one line on the screen. So if you want to go back and look at it, you keep hitting your left arrow key to scroll back and see what you typed in. So that's what we typed in, the whole expression all on one line on our calculator. Hit enter and boom, we'll have our answer. Your answer is 7/8. And the amazing thing is it actually even reduces your fractions too. What a time saver this calculator is. You agree? I mean, doing that problem manually, ladies, would have taken a lot of time. All right. So this is an amazing calculator we have here, to say the least. What an amazing machine. You know what? I'm going to show you how to simplify what's called the complex fraction on your calculator. What is a complex fraction? Complex fraction, ladies and gentlemen, is when you have a fraction over a fraction. In general, when you got like a fraction over a fraction, it's called a complex fraction in mathematics. We're going to show you how to simplify a complex fraction on our calculator. If I have 9/16 over 3/4, how would we simplify a complex fraction? Well, to do so manually, I'll show you how we'd walk through this manually. This fraction bar means division. So this is really saying to take 9/16 and divide it by 3/4. That's really what it's saying to do. 9/16 divided by 3/4. And how do we divide fractions? Well, we always change division to multiplication. And what do we do with the second fraction? Anybody remember, or have you ever seen this? Flip the second fraction upside down.
Yeah.
Now we can multiply our numerators across. 9 times 4 is what? 36. And that sits over 3 times 16, which is what? 48. And now, ladies and gentlemen, we just have to reduce this. How does 36/48 reduce? We could at least reduce it down by what? By 2, unless you can think of a bigger divisor. That'll take it down to 18 over what? 24. We can further reduce down by, let's reduce down by 6 now to go get there a little quicker. Get this thing down to 3 what? 3/4? You agree? That's your answer, 3/4. Let's type this in on our calculator now and have our calculator take care of this and give us our answer of 3/4. Okay, let's type this complex fraction in on our calculator and show ourselves how the machine can reduce that or get our answer. So here we go. Do we all have that written down on your paper, that complex fraction?
Mhm.
Okay, here we go. Go to your calculator, clear your screen. Now, ladies and gentlemen, we have to hit the fraction button. Notice my cursor sitting in the numerator, but my numerator is to be a fraction also, so I have to hit my fraction button again. Everybody see that there? Did we all get that? I started by hitting my fraction button, and then we hit my fraction button again. We type in 9/16. Move your cursor downstairs and hit your fraction button again, because the denominator has to be a fraction too, namely 3/4. Hit your right arrow key to bring your cursor up to that level. Hit your right arrow key again to bring your cursor up to the main level right there. Ladies and gentlemen, hit your enter button and we should see what for the answer. What should we see? What did I get? 3/4. Do we see 3/4? And there it is. Isn't that amazing? You have got to love this calculator. Talk about saving us some time, ladies and gentlemen. Okay. Do you think we can try this one now? Let's take this big old nasty complex fraction and have our calculator wrestle with it. 4 1/3 subtract 1 2/3, and we're going to divide, have that sit over 8 1/4 minus 5 1/2. Wow, look at that. Let's try to simplify this complex fraction. So how would we do that? How would we simplify this complex fraction? I'll tell you what, to be safe about things, whenever you have the sum or difference of numbers sitting over the sum or difference of numbers, always enclose your numerator and denominator inside parentheses for safety reasons, to stay off what's called a logical error. Okay, so we're going to type this in exactly the way we see it on our calculator. All right. So write that down and let's just go and type that in on our calculator and let's dial up what that would be. All right, we ready? Clear your screen. Hit your fraction button. Open parenthesis. 4 1/3. I have to go get my mixed number template. So second fraction key brings up mixed number template. 4 1/3. And then we'll subtract off 1 2/3. So hit your minus button. 1 2/3. We got to go get the mixed number template again. Second fraction button brings up mixed number template, 1 2/3. Hit your right arrow key to bring your fraction, your cursor up to level. Closed parenthesis. Now hit your down arrow key to dive down into the denominator. I'm going to start off my denominator with an open parenthesis. 8 1/4 now. I must type in a mixed number, 8 1/4. So hit your second fraction button to bring up your mixed number template. 8 1/4. 8 1/4. Right arrow key to bring your cursor up the level. Subtract 5 1/2 minus 5 1/2. Mixed number template. 5 1/2. Closed parenthesis. And ladies and gentlemen, look what we've accomplished. We've typed that whole nasty expression in on our calculator. You can bring your cursor up the level by hitting your right arrow key again. Now hit enter and boom, your calculator will literally negotiate this problem within a fraction of a second. Done. What's your answer? 32/33? And that's reduced too. Isn't that amazing? You have got to love this calculator, ladies and gentlemen, and the time it can save us. Can save us a lot of time, can't it? And you know, it doesn't matter if you're working with fractions or decimals or a mixture of fractions and decimals. It doesn't matter. Your calculator is going to take care of business no matter what you type in. So it's really amazing. Any questions how we've been using our calculator here to simplify rather nasty expressions here? Okay. All right. So like if I have, like, let's say I have a mixture of fractions and decimals in an expression. So let's say I want to simplify 0.75 squared plus 1/4 squared times 7. Suppose I want to simplify this expression. Well, we can definitely type this all in on our calculator, ladies and gentlemen. So let's see if we can go do that. Let's just write it down first on our paper, that expression there. Notice in between the 1/4 squared and the 7, there's multiplication. Understood. It's multiplication. Okay. So let's see if we can just write that down and type that in on our calculator. Okay. We have that written down. Okay. All right, clear your screen. And now we'll have an open parenthesis, 0.75, 75 hundredths, and we want to square 75 hundredths. Again, feel free to hit your x squared button or your general power button and then type in the exponent of 2. It's up to you. If you hit your x squared button, it squares it quicker. It just types in the square, okay? Plus, open parenthesis, 1/4. You got to get your fraction template. 1/4. And then a closed parenthesis times 7. And you don't even have to put the 7 inside parentheses. You can if you want, but it's not really necessary. And that's it. That is typed in all on one line. And then when you hit enter, you should have it. Okay. Notice your answer is taken out to what place? What place is this answer taken out to? Tenths, hundredths, thousands, and then what?
10,000.
10,000s. That's correct. So we would read this decimal as 2 and 3,125 10,000ths. Let me run that through again. We would read this decimal as 2 and 3,125 10,000ths. That's how you'd read that decimal. All right, so that's how you would read that decimal there. Ladies and gentlemen, do you know how to round decimals off? You know how to round decimals?
I've had some experience with it, but I don't remember.
Okay, all right, let's look at this here. I'm going to give ourselves a decimal here, and I'm going to have ourselves rounded off to various places here. All right, so let's take a look at this decimal here, this 29.9876. By the way, to read it properly, it would be 29 and 9,876. What place is the 6 in? Tenths, hundredths, thousands, 10,000s. So we would read this as 29 and 9,876 10,000s. We're going to try to round this decimal off to the nearest whole number. What digit sits in the whole number place? Anybody? What's my whole number place? The whole number place, ladies and gentlemen, is another name for the ones place. What digit's in the ones place? The ones place. The 9. Here's how we round decimals. First of all, we locate our round off place, which is the ones place. Then we look to the digit immediately to the right of the round off digit, and we see that we have a 9 here. And we ask ourselves this question, ladies and gentlemen, is this 9 5 or larger than 5? Or is it less than 5? What's the case here? Is 9 larger than or equal to 5 or less than 5? It's larger than 5. So what we do is we bump this digit up by 1, which moves the 9 up to a 10. And then the 1 of the 10 spills over to the 2 and gets added to the 2. So that makes that 2 become a 3. And then, ladies and gentlemen, that would be your answer. We truncate all the digits to the right thereof. So again, the 9 is in my round off place, the ones place. I look to the right, I see a 9, and 9 is larger than 5. So I bump the 9 up by 1 to a 10. That makes this 2 become a 3. So this becomes 30. And then we truncate the decimal point, and all the digits to the right we chop off. That's rounded off to the nearest whole number. Let's round this decimal off to the nearest tenths place. What digit's in the tenths place now? The tenths. Well, now my round off place is the what digit? Yeah, not that 9, but this 9. Do you agree? That's your round off place. So we look immediately to the right of the 9 and we see an 8. And we ask ourselves, is this 8 5 or larger than 5, or is it less than 5? What's the case? Well, since it's at least as large as 5, in other words, it's greater than 5, we bump the 9 up to a what? 10. So we make this become a 0. And the 1 of the 10 spills further to the left and gets added to the 9 and makes this a 10. And the 1 of the 10 moves further to the left and makes the 2 become a 3. So rounded off to the nearest tenths, ladies and gentlemen, this would be 30.0, rounded off to the nearest tenths. Notice, after we round off to our given decimal place, we chop off all the digits to the right. That's rounded off to the nearest tenth. Can we round this number off to the nearest hundredths? What digit sits in the hundredths place? What's my round off digit? The hundredths. What do you think? What's the hundredths place? Well, now my round off digit is the 8. Do you agree? That's the hundredths place. This is my round off place. We look immediately to the right of the 8 and we see a 7. We ask ourselves, is 7 larger than 5?
Yeah.
Greater than 5? Yes. Since 7 is greater than 5, we bump this 8 up to a 9 and chop off all the digits to the right. So rounded off to the nearest hundredths, this is going to be 29.99. That's rounded off to the hundredths place. Okay. I'm gonna make this digit something different than a 6, ladies and gentlemen. In fact, I'm gonna decrease its value down to, just for the sake of this last problem. Suppose our last digit is like a 3. Gotta let this dry here, the stupid white up. 3, okay. Well, suppose you want to round off to the thousandths place. What is my round off digit now? The thousandths place. What digits in the thousandths place?
So be
The 7, right?
7.
Tenths, hundreds, thousands. So we look immediately to the right of the 7, we see a 3, and we ask ourselves, is 3 5 or larger than 5, or is it less than 5?
Less than 5.
Because 3 is less than 5, we do not round the 7 up to an 8. We keep the 7 as a 7, and we chop off all the digits to the right. So rounded off to the nearest thousandths, this is 29.987. And ladies and gentlemen, that's rounded off to the nearest thousandths. So what's the cutoff value that enables me to determine whether I round up or keep the number the same? It's always what? 5 or larger, do you agree? Or less than 5? That's the question we ask ourselves.
Okay.
Okay, that's the question we always ask ourselves. All right, ladies and gentlemen, this will be the only classwork today. Here it is. I got 3 problems, and you know what? You can use your calculator, okay, as much as possible. So please do use the calculator as much as possible. Number 2 is the only one where you don't use your calculator. Go ahead and do those problems. We'll check your answers very quickly and wrap it up. We'll call this the classwork for January 13th. It's the 13th already. So see if you can do those problems there. Yeah, problem 2 has several problems because it has you rounded off the number to the nearest whole number, the tenths, the hundred, the hundredths. Okay, so there's more than one problem for number 2. Go ahead and do those problems.
Okay.
Now, number 1, I'll show you the manual way of reducing this fraction down, but you can just use your calculator to get the answer, get the reduced fraction. But I'll just give you a little extra if you want. Just curious, anybody run the last one through the calculator and get an answer? Just curious. Yes, Michael, 37 tenths. Thank you. Yeah, that'd be 37 tenths. Now, Liz, you can always convert improper fractions because that is an improper fraction since the numerator is greater than the denominator. You can convert this into an equivalent mixed number if you want. The manual way of doing that is by dividing the denominator into the numerator. 10 divides into 37 3 times with 7 left over. So you have 3 whole and 7 tenths, 3 and 7 tenths. You know, your calculator can toggle back and forth between improper fraction and mixed number too. I don't think I've shown you that. I can show you that real quickly here, how you can go back and forth between improper fraction and mixed number, okay, instead of doing it manually. So let me show you how, like 37 tenths here. Let me show you quickly on your calculator how you do that. Just, I'm going to type in 37 tenths. Okay. And now it's very easy to go back and forth between mixed number and improper fraction. Notice, ladies and gentlemen, above this key in the middle here, this times 10 to the nth power key. Do we see that key on our calculator?
Mm-hmm.
It's 3 keys above the 8 key. 3 keys above the number 8 key. 1, 2, 3. Notice above that key, it goes between fraction and mixed number. It enables you to go between n over d and u and n over d. So it enables you to toggle between a fraction and a mixed number. So in order to convert this into like its mixed number equivalent form, we hit the second key followed by the times 10 to the nth power key. Brings up all that. Now just hit enter and boom, it takes you to the equivalent mixed number, 3 and 7 tenths. If you want to go back to improper fraction, you got to hit that, bring up that function again. So second times 10 to the nth power key, hit enter again, and boom, it goes back to 37 tenths. You can always toggle back and forth between mixed number and improper fraction. Everybody see how that worked there? Okay.
Do you always want the number in the improper fraction or the mixed number?
Yeah, good question. You know, unless our problem has context to it, what is context? Well, context would be like if we're cutting a piece of wood or cutting a wire or a pipe, okay, like in the skilled trades. Well, if I tell you I want a pipe that's 37 tenths inches long, you're probably going to come back and say, what was that again? But if I tell you I want a pipe that's 3 feet and 7 tenths of a foot in length, or 3 and 7 tenths inches, then this would resonate better in our thinking. Do you agree? So when our problem has context to it, like if we're working with inches or feet or whatever, then you probably want to report your answer in what as a mixed number. But if your problem does not have context to it, like this problem really doesn't, it's not applying to any application problem. We could just leave it as 37 tenths. I do want your fractions to be reduced, but you can leave it as an improper fraction. But if we were working with like lengths of pipes or wires or wood or whatever, yeah, you'd want to report this as 3 and 7 tenths. Does that answer your question then?
Yeah.
Okay. It depends if the problem has context to it. And
so like if there was like a story problem and it was all
word problem. Yeah, story problem, application problem, word problem. We would report it as a mixed number there. All right, ladies and gentlemen, I've worn out my time. I'm sorry for going over a little bit, but there's just so much to cover. We did cover pretty much everything I wanted to cover today. That's the good news. Okay. Now, I will open up, ladies and gentlemen, your first homework from your textbook, and I will put the link on the main page of Canvas. So what I'm going to do here, whoops, right here, is on the main page, I'll put a link that says textbook homework. You just click on it and it'll take you to the homework assignment. Does that make sense there?
Mhm.
All right, when's your homework going to be due? When is your textbook homework due?
The 18th.
Well, we just bring up the schedule and we'll find out. Let's see. When was the homework due? Oh, ladies and gentlemen, homework set number 1 is due by February 10th, midnight. Notice homework set 1 is due when we do the midterm exam. That'll include sections 1.1 all the way up through 8.4 that we will cover. Do you agree, between now and February 3rd?
Okay.
So your textbook homework that I will open up and assign today will be due ultimately midnight, February 10th. Okay. And notice the only other homework that will be due after that will be homework set number 2, which will be due by March 2nd, midnight. That will only constitute material from 9.1 through 12.7. So do we see how that's working there, the homework? All right. And I'll indicate via email exactly what I want you to turn in as proof of having done homework set number 1. But I won't give you that email until we get to February 3rd. Okay? All right, ladies and gentlemen, so you have a great weekend. Like I said, I will open up your first homework assignment out of your textbook, and please do get started as soon as you can get started. This quiz number 1 here, I'm going to hold off and give you that on January 18th, ladies and gentlemen, because I want you to try to do some textbook homework first before we entertain that quiz. You see that quiz 1 there? I'm going to move that to January 18th. I will update the schedule and post a new schedule on Canvas to reflect that. Does that make sense, sir?
Yes. Do you want us to email you this classwork like last time?
Yes, yes. Please do, by midnight tonight, get me the classwork that we did today. That would be awesome. All right, that is it. I will, make a recording for this video and post the link. How do you access lecture videos? You just click on the lecture video link right here. And then I will include it down here as January, what is it, the 13th? So January 13th? Yeah, January 13th lecture. This is wrong. This should be January 11th lecture. This was back on Tuesday. I keep saying Monday. No, our first class was Tuesday. I'll change that to January 11th. And then I'll have the January 13th lecture also. All righty?
Okay.
Okay, any other questions or concerns, ladies and gentlemen? All right, you have a great weekend. Have a great weekend. And it's like a little mini break because we have Monday off, don't we? At least for Mott, correct? I don't know about other jobs, but you have a great weekend, okay?
All right, take care.
All right, we'll see you.